Hi, sixth graders. Today we are going to talk about the mean absolute deviation. It's also known as MAD or MAD. And it's a tricky lesson, so you might want to pause or rewind this video a few times until you're feeling good about this and practice when you are ready. Here are our notes for today. Our topic is called Mean Absolute Deviation. You might also see it represented with its nickname of MAD or MAD. And it's a tough lesson. We've got a bunch of different steps to do, and it makes some kids mad, and that's okay. We're gonna work on it together, and I am totally here to help you. First, we're gonna recognize what the words in mean absolute deviation mean, because these words are gonna help us understand the steps we're gonna take to find it. So the mean we already know is the average. Absolute means positive, because if we go back in our brains to when we were talking about absolute value, that was the positive distance away from zero. So an absolute number is a positive measurement, and deviation is the distance away from something. If I have a plan and I deviate from my plan, it means I went away from my plan. I walked a distance away from the plan that I had thought of. So what this means for mean absolute deviation is that we're finding the average distance away from the average. And that means we're going to end up finding the average twice. The reason that you might want to know the mean absolute deviation is you want to know about how different from the average are all of your numbers. Are they really spread out? So you're going to have a really big mean absolute deviation. That means you've got numbers all over the place. They're really spread out from the average. They're really high on one end, they're really low on the other. Or if you have a small mean absolute deviation, that means all your data is pretty close together. All of your numbers are pretty similar to one another. They're not super different or spread out. So here we're going to practice finding the mean absolute deviation. And we have 3 steps. So the first step we're going to do is we're going to take a set of data and we're going to find the mean. We're finding the average. That's step number 1. Step number 2, we're going to find the absolute deviations from that. So we're going to see, once we get an average, how far away is each number from the average. And step number 3, we're going to find the mean of those deviations. That means we're going to find the average distance away that each number was. So let's dive in and practice this together. Step number 1, we're going to find the mean of this data. So we have a 6, 9, 9, 6, and 10. So we're going to pretend these are the ages of students on a playground. So we have a 6-year-old, a 9-year-old, a 9-year-old, another 6-year-old, and then we have a 10-year-old playing. Let's find the mean or the average age of these students. So we're going to add all of these together. I'm going to add 9 and 9 to get 18. I'm going to add 6 and 6 to get 12, and then we have the 10-year-old. Let's add these up. So we got a total number of years of 40. Let's now divide that. So 40 divided by 1, 2, 3, 4, 5 students, and that would be 8. So I'm going to circle that. We have done step 1. The mean or the average age of the student on the playground is 8 years old. Even though I don't see any 8-year-olds, I know that 8 is my average or my center age out of all of those kids. Next, we're going to find the absolute deviations. So what I'm going to do is I'm going to give myself 5 spaces. Okay, because I had 5 kids. And I now need to figure out how different each kid is from this average. So if the average is 8 years old, I want to figure out how different each child is from that 8 years old. Let's take the first child. They're 6 years old, and we want to compare them with 8. What is the difference between 6 and 8? Now, some people say it's a -2. Don't forget that it has to be absolute. So we don't care if it's positive or negative. We don't care if they're older, younger, higher, or lower. We just want to know how many steps away. 6 is 2 steps away from 8. And a way to figure that out if you need to is just do 8 minus 6. You get a difference of 2. Next, we're going to do this 9-year-old. How far away is 9 from 8? We should know that it's 1 step away. 9 minus 8 is 1. We have another 9-year-old, so they are also 1 step away. 9 minus 8 is 1. And we have another 6-year-old, so 8 minus 6 is 2. Remember, we don't care if it's positive or negative. We're going to make them all absolute. And 10 minus 8 would be 2 years away. So we have done step 1. We found the mean or the average. Average age was 8. We found the absolute deviations. How far away was each number from that 8? We got 2 steps away, 1 step, 2 steps, and 2 steps. And our last step is we need to find the mean or the average of this new list. Okay, so let's add these up. 2 plus 2 is 4, 1 makes 5, and then 6, 7, and 8. So we got 8. We're going to divide it by 1, 2, 3, 4, 5. I definitely think I'm going to need a decimal for this one. 5 goes into 8 once. There's 3 left over. Okay, we got 30 now. 5 goes into 36 times. No leftovers. So my answer is 1.6 is my mean absolute deviation. That means on this playground, the average age is 1.6 years away from this. That means that most of my students are within 2 years of this average age. That means my data is pretty close. These kids are close in age, and I can verify that just by looking. 6-year-olds to 9-year-olds and a 10-year-old, they're pretty close together. Next, we're going to try mean absolute deviation with another set of data. So what I've done is I've made a set of data that represents the ride cost. So I'm at an amusement park, and this is the cost to go on each ride at that particular amusement park. And what we want to do is we want to find how close or far apart our data is using the mean absolute deviation. We want to know how far away these pieces of data are. So I'm going to find the mean. And what I will notice is there's a lot of data. So I need to really keep track of my work here. To find the mean, I'm going to add all of these up. So 15 and 12 is 27. I'm going to keep track of my work here. Let's do 7 and 20 makes 27 also. 9 and 7 is 16, plus another 10 is 26. 25 and 20 makes 45, and then I have a 35. Okay, I'm going to add all of these up. I got 160. That would be really expensive if I rode all of those rides. 160 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can do that mental math. That is $16 per ride on average. So these must be expensive rides, maybe like those fancy bungee jumping kind of rides. So we've got $16 as my mean or my average. Next, I need to find all of my absolute deviations. So I'm going to have a new list. I'm going to switch colors for this. I want to know how far away each one of these prices is from my 16. I don't care if it's positive or negative. Okay, 15 is only 1 away from 16, so I'm going to start my absolute deviations with a 1. 12 compared to 16, that is 4 steps away. 16 minus 12 is 4. 16 minus 7 is $9 away. 16 and 20, so I'm going to do 20 minus 16 is $4 away. 16 minus 9 is 7 away. 16 minus 7 is 9. 16 minus 10 is 6 away. Ooh, 25 minus 16. Well, 25 minus 10 is 15. Minus 6 is 9. 20 minus 16 is another 4. And 35 minus 16, I have no idea. I'm going to do this out. 35 minus 16. 19. Okay, so I've gotten my new list of all of my absolute deviations. So we found the average, and then we counted how far away is each one from our average. Now, let's do the average one last time, and then we will have our mean absolute deviation. Okay, so with my new list, I'm going to find my average again. 1 plus 4 is 5, plus 9 is 14. Okay, 4 and 7 is 11, plus 9 is 20. 6 and 9 is 15, and 4 and 19 is 23. Let's add these up. And 72. I'm going to do 72 divided by, I know there were 10 pieces of data. So I think I'm going to have a decimal for this. I'm going to get it ready. 10 goes into 72 7 times. It's 70 with 2 left over. Bring down my zeros. 10 goes into 20 twice. No leftovers, so I'm going to bring up my decimal. Now, if you remember, on our last mean absolute deviation, all of our ages were really close. So the mean absolute deviation was only 1 point something. This one, these rides are a lot more spread out. Their mean absolute deviation is 7.2. So they are on average $7.2 away from the average. There's a lot more variation to these ride costs. We've got some really low rides like $7. We've got a high ride up here, $35. So this mean absolute deviation, because it was higher, shows us that our data is more spread out from one another. So there you have mean absolute deviation. Like I said at the beginning, this is a tough one. You might want to watch this a few times. You might want to pause, take some notes, solve these along with me before you're ready to practice on your own. Good luck, work hard, and reach out to me if you get stuck or want to join one of our sessions for review.